Oh yeah, we're going to look at some inequalities and particularly solving some inequalities, but we're going to start off with just solving some regular equations, the likes of which you have seen before. So, off you go. I'll pause and then unpause when you're done. Don't just skip this bit, do this bit please, it'll be really useful for later. Okay, unpause. So, straightforward two-step equation here. I need to add 7 to both sides of the equation to get 56 over here. 7 take away 7 is nothing, so that's now 6. Oh, sorry, 66, isn't it? Not 56. Silly me. So we've got 66 there and 6. So I don't want 6x, I only want one of them. So I divide by that number touching the x. So 11. Yep, x is worth 11. This one, I've got y's on both sides of my equation, both sides of the equal sign. Find the side that's got fewer, because this has got 3, that's got 5, which means I can quite happily take 3y from both sides of my equation. It'll keep the whole thing balanced, because I'm doing it to both sides. The right-hand side now has 2y, and the takeaway 4 is still there. Now we're back to a two-step equation, so add the 4, because you always deal with that number touching the letter last. Okay. 2y, 12 plus 4 is 16. And then, of course, I don't want 2y, I only want the value of one of them. So, divide by the number touching the letter, divide by 2. So, y is worth 8. This one, though, there is a fraction in here, but it's only on part of my equation. So I need to deal with the plus 5 first. So I'm going to take away 5 from both sides of my equals sign. So the left-hand side is now 3y over 2, and the right-hand side is now 7.5. I've then got a fraction, and the whole of the left-hand side is divided by 2. Quite Murphy, exactly, yep. So we're now going to times by 2. Oh, the fun of lockdown. And the right-hand side is now 15. The left-hand side, you don't times the top by 2. I'm timesing it by 2 to get rid of this dividing part here. Hold on, just need to shout at the dog. That seemed to help. So we have 3y on the left-hand side. Right, now we divide by 3 to get y equals 5. Yep. Okay, quadratic equation, because I've got x squared plus x and then a number. Now this x here, remember this is 1x, that might help. I've got minus 12, so let's find the factor pairs of negative 12. Well, it could be 1 times 12, 2 times 6, or 3 times 4, but of course this is negative 12, so it might be negative 1 times 12, or negative 2 times 6, or negative 3 times 4, or, of course, it could be the same numbers, but the second number negative, so 1 times negative 12. So when you've got this negative there, always remember just to write your factor pairs out twice. Once with the first number negative, once with the second. And we're trying to find that factor pair that adds together to make that coefficient of x, makes 1. And that would be this one. Negative 3 and positive 4 would make positive 1. So we're going to factorize it. Put those numbers in a bracket with x, so x minus 3, and the second bracket is x plus 4. That equals 0, just like the question does. And then you're trying to make these brackets one at a time equal 0. So we'll make that one equal 0. We'll make the second bracket equal 0. The first one happens when x is positive 3, so that's one solution. And the second one happens when x is negative 4. That's the second solution. If you're not sure about these, you really need to go back and practice them. Choose a bit on Dr. Frost or go and watch the other video on solving quadratic equations, which is on my YouTube. Right, this one, it is a quadratic equation, but it needs to equal 0. Now to do that, I'm going to add 7 to both sides. So we'll have x squared take away 8x plus 7. Okay, let's factorize that then. Or factor pairs for 7, sorry, that'll be 1 times 7, and that's the only one. Now, 1 times 7 is positive 7, but I need to make that coefficient of x. I need to make negative 8. Now, that's only going to happen if both these numbers are negative. And that's fine, because when two negatives multiply, they make a positive. So they'll make positive 7 when they multiply, negative 8 when they add. And let's put that in brackets. So x minus 1 and x take away 7 equals 0. Again, each of those brackets, now you've got them in double brackets, you want them to equal 0. When's that going to happen? Well, that's going to happen for this one when x is positive 1. That's one solution. That's going to happen for this one when x is positive 7. So that is a second solution. There you go. Quadratic equations generally have two solutions. Sometimes it's a repeated solution. None of these are, but it could be. But they generally have two. Okay, let's look at this then. So, bit of revision possibly. Inequalities. Right, inequalities represent a range of answers, not just a single solution. So before, we had an answer like, for example, x is 2 or x is 3. Well, that's a single solution. Well, now we're going to use our inequality signs, x has value of 2, to show that x has a range of answers. So in this case, x is bigger than 2, anything higher than 2. Not 2 itself, but anything higher. So it could be 2.1. It could be 2.001. It could be 3 million. Anything, literally, bigger than 2. And there's an infinite number of things that it could be. Now, the thing about inequality signs is, it's all about looking at the sign. Now, I like to think of which side is bigger, right? So this, people say crocodile mouth, don't they? So this left-hand side is more open. So that side is bigger than the pointy end. 2. X is bigger than 2. But surely we could actually write that the other way round. Oh, hang on. We'll come back to that in a second then. This one, doing it in the wrong order, this one says x is 2 or anything bigger. So this time, yeah, sure, we've got all those infinite number of answers that it could be. 2,000,001 maybe. But actually, it could also be 2 because we have this extra line. So it means x is 2 or anything bigger than 2. Yeah, this is what I was going to get at before. The big end and the pointy end. The pointy end is the smaller side. The big end, open end, is the bigger side. So these two things are actually equal. This thing here that you could read as 2 is less than x, you could equally read as x is larger than 2. Which brings me on to how we sort of say these, which is x is greater than 2 is how we generally say this top one up here. X is greater than 2. And the one on the right hand side we'd say is x is greater than or equal to 2. So the greater than comes first and then we do say equal after that. Mephi, do be quiet. I know you want to chase the cat, but I've got stuff to do. Okay, what about though we could do it the other way. Things don't have to be bigger than something else. They could be less than something else. So this one here, the pointy end is at the left hand side, so that side is smaller than anything on the right hand side. So x is less than 2. You know, x is literally anything less than 2. So that could be 1. It could be 1.9. It could be 1.9 recurring. Literally anything up to 2. It could be negative 1,000,000. You know, anything that is less than 2 is perfectly acceptable. Mephi, I am trying to teach. This doesn't happen in my classroom. It shouldn't happen here. X is less than or equal to 2. So again, and it's anything that's less than 2, but also does include 2 as well. So x is 2 or anything less than it. Okay, so these extra lines, that's what it means. It's a bit like an equals sign. I mean, usually if we're handwriting it, I think most people would actually put the equals bit in line with the diagonal bit. But computers tend to put them flat across the bottom. But, you know, usually it's like that. So it's like an equal sign or less than as well. Right? Hopefully pretty easy to remember. So in that case, I want you to use, there's no equals on these ones because it's just two different separate numbers, but either the less than sign or the greater than sign in each of these, please. And then, oh, hang on. There's no pause sign on that, so I'm just going to write. Pause. Pause the video and then unpause when you're done. Okay, 3 and negative 2. Well, 3 is bigger than negative 2. 2.5 and negative 2.6. Well, negative 2.5 is bigger than negative 2.6 because it's negative. This one is definitely smaller. 4.9 recurring or 4.9? Well, 4.9 recurring is bigger than 4.9 because, you know, there's 4.9, while the other one has another 9 after it. In fact, it has an infinite amount of 9s after it. What about a third and 0.3? Well, a third is bigger than 0.3 because a third, if we were writing it as a decimal, would also be 0.3 recurring. So 0.33333, etc., etc. That's bigger than 0.3. It's got some extra stuff in it. Which is bigger, negative a third or negative a half? Well, let's think about which is bigger in the first place. So a third is a bigger part of a circle. No, sorry, what am I talking about? It's a smaller part of a circle, but we're talking negatives here, which means the negative third is going to be bigger than the negative a half. Yeah, hard one to get your head around sometimes with that. How about 5/13 and negative 7/17? Well, anything positive is going to be bigger than anything negative. So they're all greater than. Yeah. Cool. Let's move on. Right, representing inequalities on number lines. Let's say some of this is revision, which is why I'm going a bit quicker, but let's just double check we know these ones. What about that? Okay, how would I say that, first of all? I would say x is greater than or equal to -1. So either -1 or above. At least -1 is probably another way of thinking of it. And I can put this on a number line. Now, we need to be able to represent all 4 of our different symbols. So less than, greater than, less than or equal to, or greater than or equal to. And here's how we do it. Now, if it's either less than or greater than or equal to, so you've got the extra line on there, meaning it's equal to as well, we have a closed circle. So it's completely shaded in, it's a closed circle. Then if we've got just less than or greater than, so there's no equal sign, we have an open circle. Now I kind of think of this like, the signs at the top here have an extra bit of ink, don't they? They have the equal sign as well, so my circle also has an extra piece of ink. Yep. If there's no extra piece of ink, then it's just an open circle. It doesn't include the number. The number sort of falls through. So the way I do this, so first of all, ignore the, well, not ignore the sign, but look at the number. What is it? -1. Well, there's -1 on my number line. So above it, put the appropriate circle. Now this is greater than or equal to, so I put a filled in circle. And then I put an arrow in whichever direction I need my numbers to go. Now x is bigger than or equal to -1, so it goes to the right. It goes through all the numbers which are, you know, in my set of numbers, which are bigger than -1. So put your circle in first, then your arrow in the right direction. So this one, x is less than 3. So with your number line, put the appropriate circle. Now there's no extra ink on this. It's just less than 3. It doesn't include 3. But I find 3 on my number line, and I put my appropriate circle. Yeah, that's right, because that's -3. Oops, that's embarrassing. It's, you know, this talking and writing stuff is harder than it seems at the same time. So we've got an open circle at 3. Then I need to put my arrow in the appropriate direction. And in this case, it's going left because we want everything less than 3. Which, of course, -3 is less than 3. That's probably why I put that in. Just to, you know, highlight the point. Okay, x is less than -2. So again, on your number line, identify for definite, don't make any mistakes here, where -2 is, put the appropriate circle. There's no extra ink here, so there's no extra ink on my circle. It's above -2, but sort of -2 falls through it. It doesn't include it. Now, which way does my arrow go? Well, x is less than -2, so it goes to the left. Yeah, good. In that case, your turn. There are 4 for you to do. So you just like sketch out a little number line on your sheet of paper or your book. And, you know, they can be these kind of empty number lines where you just put 0 and maybe -5, +5 and put your number maybe. Unpause when you're done. Okay, we have unpaused. So first of all, x is greater than or equal to 3. So find 3. And put the appropriate circle above it, which in this case is a filled-in circle. And x is bigger than 3, or bigger than or equal to 3, so we put an arrow to the right. Right, x is less than -1, so find -1. Put the appropriate circle. In this case, it's an open circle because it's less than -1. And the arrow goes to the left because it's less than. Here, x is greater than or equal to -2, so find -2. Put the appropriate circle. This time it's a filled-in circle because it's greater than or equal to, so it includes the number itself. And put an arrow to the right because x is bigger than that. Number 4, x is greater than 1, so identify the number. Put the appropriate circle. Now this time it's an open circle because it doesn't include 1. It's just greater than 1. And again, it's greater, so it goes to the right. Good. Hope you got those right. In that case, at this time, here are some inequalities. I want you to write down what those inequalities represent, what these number lines represent. Remember, look at the number, look at the circle, and then which way does the arrow go. Unpause when you're done, please. Okay, unpause. Right, here we go. First one, x is greater than or equal to -2. Number 2, x is less than 1. Number 3, x is greater than -4. Number 4, x is less than or equal to 0. Number 5, x is greater than 2. Number 6, x is less than or equal to -1. Number 7, x is less than or equal to 3. Number 8, x is greater than -2. And number 9, x is greater than or equal to 1. Cool. Onwards. Okay, so let's do some solving of inequalities now. Let's have a quick look. All right, firstly, let's remind ourselves. Now, the solution to an inequality is a range of answers, not just one fixed solution. So the process is exactly the same, though. It's not going to be any different at all. Now, on this, if this was an equal sign in here, I would, first of all, deal with the -4, right? I'm going to add 4 to both sides of my equation. And then 4 take away 4 is nothing. So the left-hand side is 6x, and the right-hand side is 30. Now, all I'm going to do here is just use the same sign that's in the question. Greater than. So 6x is greater than 30. The process is exactly the same as solving a normal equation, except there is one exception to that, which I will show you later. Now, we don't want 6x, we only want 1, so we divide by that number, touching the letter, to find the value of one of the x's, where 30 divided by 6 is 5. And again, I'm just using the same sign that's in the question. So the answer to this is x is bigger than 5. So with any number bigger than 5, and there are an infinite amount of them, all of those would make this equation work. Okay, so the process is exactly the same. Let's try another one. Okay, I've got a fraction in here, but it's only under part of one side of my equation. So I'm going to deal with this -4 first. That's the easy bit. So I'm just going to, again, add 4 to both sides. And we will be left with the left-hand side will now be 2x over 3, and the right-hand side will be 6. And I use the same sign that's in the question. Less than or equal to. So 2x divided by 3 is less than or equal to 6. Okay, now the left-hand side, let's times it by 3. Because I don't want this fraction. I want to get rid of the fraction. Don't want it there. Don't like fractions in equations. I mean, despite the fact that fractions obviously are our friends. So 2x is less than or equal to 18. So first of all, divide. Well, not first of all, this is the last step. Divide by 2, because I don't want 2x, I only want 1, so we halve everything. to get x is less than or equal to 19. So again, process is exactly the same. You just make sure you use whatever sign is in the question. Right, your turn then. Press pause and unpause when you are done. Okay, you are done. So let's have a look here. Let's add 8 to both sides. So the left-hand side is 7x, and the right-hand side is 35. And put in the greater than sign, just like the question. Then we'll divide by 7 to get x is greater than 5. Yep. This one, okay, we've got a fraction on here, and it's on the whole of the left-hand side of my equation, so I can safely deal with that first. I'm going to times by 4, which will cancel out that fraction. So just give 5x minus 1 on the left. Now 4 times 6 is 24, and put in the sign that's in the question. So 5x minus 1 is greater than or equal to 24. Add 1 to both sides, and we will have 5x on the left, and we will have then what we've got, greater than or equal to 25. I don't know why I paused there, no idea. Right, but we don't want 5x, we only want 1, so we'll divide everything by 5 to get 5 is greater than or equal to 5. What a lot of 5s, eh? But yeah, just use the same sign that's in the question. Okay, this time inequality, we've got x's on both sides of my inequality, so find the side that's got fewer, and that's the side we're going to remove. So we're going to remove it by taking away 2x from both sides. So the right hand side is now just 24. The left hand side is 4x minus 4. Let's add 4 to both sides then. Let's try and write a bit neater, shall we, Mr. Nias? So 28. 4 take away 4 sort of disappears. And 4x is less than 28. The last step, divide by 4. Because we don't want 4x, we only want 1. X is less than 7. And apparently my Mac is low on power, so I shall deal with that in just a second. Okay. While I'm dealing with that, you've got some questions for you to solve, please. Have a go, all 8 of those. Pause the video, unpause when you are done. Off you go. Okay, right, the power supply is put in and you have unpaused. So here are the answers. First one, x is greater than 6. Second one, x is greater than 3. Third one, x is less than 8. Fourth, x is greater than or equal to 12. Then x is greater than 5. X is less than 9. X is greater than or equal to minus 4. And x is less than 5. Okay, now if you struggle with those, obviously get hold of me, or just go back and have another look and just check out where you're going wrong. Look at the solutions to the previous answers. So, this is the exception. Be careful when dividing by a negative. Okay, and I'll show you exactly what I mean. So here's a regular equation. Well, it's an inequality, isn't it? Because there's no equal sign. But we would solve that usually by dealing with the number touching the letter last. So I'm going to deal with this 5 first by taking it away. That's fine. 5 take away 5 makes that disappear. Put the inequality sign in. Minus 3 take away minus 5, or negative 3 take away. That is negative 8, because you start with negative 3, take away another 5 to get negative 8. Now at this point, you would normally, and we will here, divide by the number touching the letter, which is a negative, so we divide by that. Divide by negative 2. Now we are here dividing by a negative. Now negative 2 divided by negative 2 just leaves 1. Negative 8 divided by negative 2 is 4. Nothing special about any of that. But at this point, you need to reverse the sign. I know, right? You just need to reverse the sign or it doesn't work. And I will prove to you that that is the case. Let's presume that I'm just going to write it in red down here, right? So this is our thinking bit. Let's presume that I haven't reversed the sign and it still says x is greater than something. So x is greater than 4. So let's pick a number greater than 4, 5. All right, let's go back to my equation and let's put 5 into the equation and see if it's true. Because if it is right, then this equation will be true. Well, 5 take away 2 lots of 5 is 10. Oops. Take away -3. 5 take away 10 is -5. Then we end up with this problematic moment where we're trying to say that -5 is bigger than -3, which is clearly wrong. -5 is lower down our line and is less than -3. So you have to reverse the sign. Essentially in here, when you're divided by a negative and you end up changing the signs, you need to reverse your sign just to face the other way. Whatever it is, face it the other way. Another one here. Let's change back to my blue. So deal with the number touching the letter last. So I'm going to add 8 to both sides of this. So we have -3x is less than or equal to 18. And then I've got -3, so I'm going to divide by that -3, that number touching x, to get x is, and then 18 divided by -3 makes -6. I've divided by a negative, which means I need to reverse my sign to make it work. Yep. Again, let's just presume that I didn't. I know you're thinking, oh, just get on with it. But no, let's just prove it. So let's say that I didn't reverse my sign and it said x is still less than or equal to -6. So something less than or equal to that. Well, let's take -6 itself, all right? Won't that work? Oh, hang on, because the equals is included in both. Right, let's take something smaller. Let's take something smaller than -6. Let's say -7, right? That's smaller than -6. So -3. Let's do -7. Take away 8 is less than or equal to 10. -3 times -7 is 21. Take away 8 is less than or equal to 10. 21 take away 8 is 13. Is that less than or equal to 10? No, it's not. 13 is definitely not less than or equal to 10. So it doesn't work. You need to reverse the signs. When you're dividing by a negative, reverse the sign. Yeah. So I think 2 for you to do here. Yeah, 2 for you to do. Unpause when you're done, please. So let's go back to my blue. We are going to take away 6 from both sides. 8 take away 6 is 2. And the left-hand side is now -x divided by 5. I'm going to times by 5. So the right-hand side is 10. The left-hand side is -x. And how am I going to change this? Well, I want to effectively, I am dividing by -1. I'm dividing by a negative, which means, look how the signs have just sort of basically changed on both sides. I reverse my sign, so x is greater than -10. It's a really important point that you need to remember this. This one, we would have times it by 4 first of all. The computer's being a bit slow here. 1 take away 6x is greater than or equal to -32. I'm then going to take away 1 from both sides to get -6x is greater than or equal to -33. And then divide by that number touching x, that -6. Oops. divided by -6. Okay, right hand side divided by a negative, so that is going to turn into a positive, which is 5.5. -6 divided by -6 just leaves positive 1x. And reverse your sign. So x would need to be less than or equal to 5.5. Okay, just really important point. When you divide by a negative, reverse the sign. Okay, off to Dr. Frost with you to do some solving inequalities, and be really careful with all of these and try and get them all right, please. Off you go. Bye-bye.